look at interest and how interest works. So you guys know when you deposit money into a bank, you sometimes get interest, or in credit card, you have to pay interest on the principal not paid. So we're going to take a look and see how that interest accrues. So in this first one, a person invests $500 in an account that earns a yearly interest rate of 4%. How much would it be worth after 10 years if the compounding frequency was once per year? So this means that interest is checked once a year. So you deposit that 500, and then you earn 4% of that. So we know from the last unit, 1 plus 0.04 to the 10th power. And we can type that in here. Let's see, 500 times 1 plus 0.04 to the power of 10. So we have $740. Now, this next one here, let's see what it says. If we take a look at letter B, it says, how does this change if your interest being checked is quarterly? Why wouldn't you multiply it by 1.4% each quarter? Well, 4% is for the total year. So if it's checking each quarter, as this next question says, how much would you assume to earn each quarter? Well, 4% divided by 4, you'd assume it's 1%. Well, how does this change? Well, let's see. We started with, I already forgot how much money we started with, $500. And it's checked, so 1 plus our interest of 4%, it's divided by 4, but it's not just checked 10 times anymore. It's checked 10 times 4. So we can go back here and see how much money we have. 500 times 1 plus 0.04 divided by 4 to the power of 4 times 10. So we have $744. Well, how would this change if it's monthly? Well, it would be 500 times 1 plus, oh no, this died. Let me see if I can, oops, go back. 1 plus 0.04, it's checked monthly, times 10 years, but 12 times each year. So we can go back here, and one thing on the calculator, we can just arrow up here. So instead of this 4, that's supposed to be a 12. And then out here again, that is supposed to be a 12. So we have $745. So as you guys can see here, it does make a difference. And as it says on this next part, for a shorter compounding period, we get to apply the interest more, but it's at a lower rate. So exercise 2, you invest $1,000. It's 2%, but it's compounded monthly, so we divide that by 12. So that's each time it's checked, and it's checked at a total of 20 times 12. So once again, we have 1,000 times 1 plus 0.02 divided by 12. I think it was 2%. To the power of 20 times 12. So $1,491. So if we were to generalize this, as it says on the next page, how would we generalize this? Well, we start with our principal, and it's 1 plus, we take our rate, but we divide it by how many times we're checking it, and then it's to the n times t. So when we look at this example, we're going to check some things. You're investing money, how it would be compounded quarterly, monthly, and annually, and daily. Well, I'm going to add annually here. It's not on there. So we want to check it. What's the difference if it's annually, quarterly, monthly, or daily? Well, all of these are going to start the same. They start with 500. 1 plus 0.05. Annually would be just 1, so 7 times 1. It's only checked 7 times. This one, 1 plus 0.05 quarterly, so divided by 4, 7 times 4. 500, 1 plus 0.05 divided by 12, 7 times 12. And daily, 1 plus 0.05 divided by 365, 7 times 365. So let's see here, 500 times 1 plus, I keep forgetting 5%, so 0.05 divided by 1 to the power of 7 times 1. So there's annually. Go back here, we said quarterly, so this needs to be a 4. Go back here, and that needs to be a 4. Quarterly. We had monthly, so we switch these to a 12. And then we had daily, so 365, 365. So as you guys can see, you get more money if it's checked more frequently. So what happens here is with computers and all this kind of stuff, it's gotten so it's constantly checking it. So if it's continuous compound interest, what happens is our principal and rate and time are still there, but that number in the middle, it goes to this value of E. And you can find E on your calculator. Do you see it right here? So if you wanted to find what E, the value of E, just E to the first power, is 2.71 is what happens. So if you're investing this 2% continuously, we use 350 times E to our rate, and then it says for T years. So after 20 years, we'd have 350 times E to our rate times 20. So we have 350 times E. Our rate is 2% times 20. So continuously, we would end up with $522.